There are many different methods for performing a penetration test, which evaluates the security posture of a company, but in this video, we're going to focus on web applications. Web application penetration testing is comprised of four main steps, including information gathering, research and exploitation, reporting and recommendations, and remediation with ongoing support. These tests are performed primarily to maintain security software code development throughout its lifecycle. Coding mistakes, specific requirements, or lack of knowledge in cyber attack vectors are the primary purpose for performing this type of penetration test. In this video, you'll learn the steps on how to perform security testing on a web application, as well as the popular tools used during a web application penetration test, along with real-life examples. What is web application penetration testing? Web application penetration testing involves a series of steps aimed at gathering information about the target system, finding vulnerabilities or faults in them, researching for exploits that will succeed against those faults or vulnerabilities, and compromise the web application. The Open Web Application Security Project, or OWASP, is a community that focuses its efforts solely on discovering and reporting on web application security vulnerabilities. Their reputable list of top 10 security flaws is updated every year to reflect the global trends in the security of web applications. OWASP also publishes articles and security tools that are most practiced. Why web application pen tests are performed. Due to the enormous expansion of web applications, more and more internet resources are being spent on developing the software, as well as configuring the applications to work properly in this new landscape. This newfound frontier has, however, opened up another vector of attack that malicious hackers can use for their personal gains. Considering that some web applications hold sensitive data, it is important to keep them secure at all times, especially since a lot of them are publicly exposed to the internet. Performing the web application penetration testing as part of your software development lifecycle, or SDLC, process would be the best and most cost-effective strategy in fighting off web application vulnerabilities. The software development lifecycle is a general list of guidelines aimed at increasing the success of a software that is being developed for future use. SDLC defines a set of steps to take in order to come up with a better product that is more convenient for the end user and also takes into account the most cost-effective way of doing so. Software testing is a big part of the SDLC process and involves several key parameters or events. Through various stages of the development process, from brainstorming to coding, an opportunity is provided to engineers and project managers to come up with the most effective way of satisfying their client needs by producing the best application with the least amount of mistakes behind it. Defects are usual omissions that programmers make. Faults are different from defects in the way that their presence could allow a malicious attacker to exploit the application and create a dangerous condition or scenario whereby personal information can be compromised or access to system by unauthorized users could be granted. Technical debt, which is time developers spend going back to develop code to fix errors or implement updates, may accrue, especially when security is an afterthought. This happens when code is expedited before it is thoroughly tested and rushed into production. Therefore, testing for defects is usually less expensive in the early stages of the SDLC process compared to defect testing late in the SDLC process. Patching the software will occur during the SDLC process if faults or vulnerabilities are found to be present in web application configuration. What steps and methodologies are used to perform a web application penetration test? To emphasize the difference between an application and a web application, penetration testing the web application mainly focuses on the environment and the setup of the web app. In other words, testing the web application focuses on gathering public information about the web app and then continuing to map out the network involved in hosting the web app. Investigating for possible injection tampering attacks and the actual learning and handling of the application comes later. Step 1. Information gathering. Information gathering, or the reconnaissance phase, is the most important step in any penetration testing process, as it provides you with a wealth of information to identify vulnerabilities easily and exploit them later. Think of this phase as a foundation to a pyramid you are trying to build. There are two types of reconnaissance depending on the type of interaction you want to achieve with the target system. They include passive reconnaissance and active reconnaissance. Gathering information that is already available on the internet and doing so without directly interacting with the target system is called passive reconnaissance. Most research in this phase is done online using various websites, beginning with Google. The first step often involves using Google syntax, enumerating website subdomains, links, and more. For example, if subdomains of a certain website are of interest, you can use the following syntax to narrow down the Google search results: site, and then the domain. You can use Wayback Machine to view how a certain website looked a while back ago. This website can help you interact with the target of a web application without directly coming into contact with it. You can also probe the old version of the website and note down any characteristics that might help you later in the research and exploitation phase. In contrast to passive reconnaissance, active reconnaissance directly probes the target system and retrieves an output. Examples of active reconnaissance includes fingerprinting the web application, using the Shodan network scanner, performing a DNS forward and reverse lookup, a DNZ zone transfer, and more. Fingerprinting a web application involves gathering information about the web app, such as the scripting language used, server software and version, along with the operating system of the server. Much of this can be done using the Nmap network scanner. Run the Nmap against the target IP or the target IP range and note down all open ports and services that are running, along with the above-mentioned information regarding the OS version. Using the Shodan network scanner, you can identify additional information regarding the hosted web app if publicly available on the internet. Shodan provides vast information regarding any publicly available IP that it scans. Information range from geolocation, port numbers opened, server software used, and other useful details. To perform DNS zone transfer, use the nslookup command to identify the DNS servers. Other options are websites specifically made for DNS server identification. After identifying all the DNS servers, use the dig command and attempt the DNS zone transfer. Identifying related external sites is an important step in the information gathering stage, as there is usually traffic flowing between external sites and the target site. This is done easiest with Burp Suite, which we'll cover in more detail later. Responses from head and option requests will most definitely reveal the web server software and version. Sometimes the responses contain even more valuable data. You can easily intercept this information by visiting the target website while having Burp Suite's Intercept On feature turned on. Error pages can also provide a lot of useful feedback regarding the version and type of server the website is run on. Based on this information, you can start visualizing the environment of the web application. Simply modify the URL of the desired website and try to cause a 404 not found error. In this example, a website form not found page reveals the server and its version. Examining the source code can also provide a lot of useful information that you can use later to find a vulnerability. By examining the web page code carefully, you'll be able to determine the application environment and overall workings of the application. In this screenshot, we can see that the website is running on Apache server version 2.2.14. It's vital to document everything in an organized manner during your investigation gathering phase. This will give you a baseline from which you will continue to further study the target and hopefully find vulnerabilities in the system later to exploit. Next, we will introduce some of the most popular tools used for application penetration testing and demonstrate some techniques regarding security scanning, SQL injections, password brute force cracking, and other important penetration testing techniques you can use. Step 2. Research and exploitation. There are a sea of security tools at your disposal when it comes to performing web application penetration testing, and most of them are open source. However, narrowing down your choice to just a few tools can be challenging. That's why the reconnaissance phase is so important. Not only do you find all the necessary information you need in order to find vulnerabilities and exploits later on, but you can also narrow down the attack vectors, and hence, the tools you can use to accomplish your goal. The entire penetration testing process depends deeply on the reconnaissance phase and the discovered vulnerabilities. Finding the right exploit and gaining access into the system is far more easier with a thorough investigation. Tools such as online scanners and search engines can help you passively collect information about your target. Use Nmap to enumerate the target system and discover live ports. Here we've provided a list of popular tools that are commonly used during web application penetration testing. For automated web application vulnerability scanning, sniffing, and exploitation stages, you can use tools such as WAF Scanner, Burp Suite Toolkit, SQLMap, and various password cracking tools such as Hydra or John the Ripper. It's important to note that there are many other tools that are available at your disposal as part of the Metasploit project. Metasploit framework in Kali Linux will definitely be the go-to choice, but you can also supplement it with some other industry best tools specifically designed to aid in web application penetration testing. W3AF, or Web Application Framework, is a security scanner mainly used for discovering vulnerabilities. You can use W3AF in almost every web application penetration testing engagement to quickly probe the target website and its hosting server. To start, open the W3AF console by typing cd W3AF. Once in the right directory, type /W3AF_console to open the W3AF. Next, type in target, set target, and then the range, and hit enter. Type back to jump up a directory, and the configuration is going to be saved. Finally, type in set plugins in order to choose the desired scanning options. In this case, choose all by typing audit all, and type back to return one directory. Write start, and run the scan. Once the scan is complete, W3F will report on vulnerabilities the scan found. In this case, W3F found that the target system was running on Apache Server version 2.2.8 and PHP 5.2.4. Both of these versions are vulnerable to CSS or cross-site scripting attacks, as reported by W3AF. In summary, W3F has more features related to exploitation, but are too vast to show in this video. Nonetheless, it is a fast and easy way to quickly gather information regarding the target system. Burp Suite is a web application penetration testing tool that comes in two options. The open source version is free to be used by anyone, but with various features missing from the tool. The commercial version of Burp Suite offers a lot more automation and capabilities and is licensed to many penetration testing companies. The various capabilities within Burp Suite make it an all-around web application security testing tool that can be used throughout the entire penetration testing process. Gathering HTTP traffic with Burp Suite is easy, and the possibilities are vast in the area of exploitation. For the purpose of demonstrating the most useful aspects of Burp Suite, we've included an example of capturing HTTP traffic with Burp Suite and then performing an SQL injection attack using SQLMap. To start, open Burp Suite by navigating to the left side of your Kali Linux desktop and find Burp Suite in the category of Web Application Analysis tab. After loading, make sure your Intercept tab has Intercept is on selected. Next, set up Burp Suite to act as your web proxy in your browser. Open Preferences, go to Advanced Settings, Connection Settings, choose Manual Proxy Configuration, and fill in the IP address and port numbers 127.0.0.1 and 8080. Now that everything is set up, navigate to your target website through your browser and insert a 1 in the vulnerable part of the application's URL. In this case, the vulnerable PHP version allowed us to inject a 1 after the title section and confirmed that an SQL injection is possible. With the captured traffic, Burp Suite is no longer needed and the Intercept is on can be turned off. Save the captured traffic to a file and exit Burp Suite. In order to perform the actual SQL injection, we're going to open SQLMap and perform the attack. But first, a bit of background on SQLMap will make you realize just how useful this tool is. SQLMap is one of the best automated tools out there in open source form. It eases the process of performing SQL injection attacks and provides access to the compromised database servers. One of the main features includes fingerprinting of the database, scanning for vulnerabilities, and possible exploitation. To continue off from the previous captured HTTP traffic in Burp Suite, we're going to demonstrate the process of performing a successful SQL injection attack using SQLMap. Type in SQLMap-R, insert the name of the saved text file, -p title. This will effectively run SQLMap and, using the provided file containing the captured traffic, attempt to inject code after the title section of the URL of the vulnerable web application. After the scan is complete, SQLMap reports on the application and database version, along with details regarding all the injection attempts made. Finally, we will attempt to launch a SQL shell and gain access to the backend database. Type SQLMap-R, again name of the saved text file, -p title, -SQL-shell, and hit enter. This method can be very effective if the right access to the database is made that will allow you to perform actions such as read, write, or delete. Another method to perform SQL injection attacks is to run SQLMap against the target IP and try to gain access to the database. For demonstration purposes, we have chosen the available BWAP web application that is vulnerable to attacks. Next, execute the following command that will attempt to inject SQL code after the title=1 section of the provided web app target URL. SQLMap will run and ask you to confirm the detected version of the database. Type yes and continue the scan. Next, continue to look for databases available within the environment by adding the -dbs after the specified target. After SQLMap detects the available databases, try to list out the tables of one of the databases by adding --tables-d and specifying the table name. Since our exploit was successful, we will proceed to gain as much information as possible. The users table in the BWAP database might reveal more sensitive information. Dump the users table by typing the target URL, specify the action, database and table name, and hit enter. SQLMap will automatically detect that the users table contains password hashes and ask if you wish to store them for later dictionary brute force password attacks. Save the hashes to a file and choose the default dictionary option and run the brute force scan. Once completed, SQLMap will present the reported results of the crack. You do not need to use the default password cracking feature in SQLMap to achieve the same results. Some of the most popular password cracking tools that can help in additional password cracking efforts are Hydra and John Ripper. There are many online scanning tools that can automatically provide you with a comprehensive security scan of a desired website. This can be used as a quick method to confirm present vulnerabilities. The same results can be achieved using W3A framework. To test for this attack, penetration testers usually intercept HTTP communication between client and the server and use this traffic to exploit target systems. Sometimes applications use third-party tools for certain functionalities. This exposes the whole application to the same risk the third-party tools have. Look for publicly available vulnerabilities and exploits in software vendors the application uses and test them out. There are thousands of possible attacks in the wild that exploit applications, servers, and databases altogether. Other common attacks that need mentioning are session fixation attacks, session hijacking attacks, and binary attacks. Step 3. Reporting and recommendations. Like writing any other penetration testing report, web application reports are no different. There is a link in the description below of a sample report that you can use as reference. The structure of the report should be clear and concise, with adequate amounts of data to support your findings. Make sure to stick to what methods worked and be as descriptive as possible. By writing down the successful exploits and categorizing them by criticality, you will help the client company focus its efforts in fixing the most critical parts of their system. Some companies make sure they always write a report for the business-oriented people, so that both client IT staff and higher management understands the report clearly and to what degree they are exposed to the risk. Step 4. Remediation and ongoing support. Many companies find themselves not able to remediate all the vulnerabilities a penetration test revealed. It is best practice to mitigate critical and high vulnerabilities first and focus on the medium and low afterwards. Prioritization plays a big role as the likelihood of each vulnerability being exploited varies. Some vulnerabilities detected are possible, but not without previous access to the internal system, and some vulnerabilities carry the risk of remote code execution and should be adequately prioritized to reflect the likelihood and impact. Many penetration testing companies offer a retest as part of their contract and will provide you with a secondary penetration test of those identified vulnerabilities to verify the mitigated vulnerabilities found have been remediated in the previous test. This is where you can work closely with your security and IT teams to resolve any vulnerabilities that are found after the first test has been conducted. Unlike the old school applications, web applications offer a lot to the market in terms of commerciality and usefulness. They bring functionality to the internet, but sometimes at a cost. These systems are usually publicly available and can be exposed to the internet at all times. Because of the growing popularity and presence on the internet, web applications usually carry vulnerabilities in their design and configuration which malicious hackers find and exploit. Since these systems are almost always internet-facing, they carry a greater risk with them and should automatically be prioritized when it comes to penetration testing. If the application handles some credit card data, personal information, or even health records, it would be in the company's best interest to perform annual web application penetration testing in order to meet regulatory compliance that most of the data requires. In cases where penetration testing is not required, it is highly recommended as the best means to meet the best security standards than to avoid performing it. With varying tools to choose from, web application penetration testing has developed a much more structured approach to automated and manual testing. Choosing any open source security solutions is highly recommended, with the availability of commercial versions of the same tool with upgraded capabilities. To end with, web application penetration testing involves testing the application's environment, database connectivity, source code, bad data, and error data in order to find vulnerabilities and exploit them.